Welcome back. We're going to begin today with a little bit more discussion of initial value problems. Last time we said that an initial value problem is going to have two pieces. One is going to be a differential equation. If we're looking at a first order, that means first derivative differential equation like this. This is our differential equation. That's our first part. The second part of an initial value problem is going to be what's called initial conditions. So this tells us the value of the solution at some a particular time. And often this output is called the initial value. This is the value we have to go through. If we're looking at a second order differential equation, so here this says the second derivative of y is some function that depends on time, on the function y and its derivative. So this is expressing the second derivative in terms of the original function, its derivative, and the independent variable. So this is some differential equation. And this time when we look at initial conditions, we are going to we're going to be able to tell this is an initial value problem because we're going to be evaluating the function and its derivative at the same time. Okay. So there are variations of this. In 251, we'll be looking at these especially where we might be given values of the function at two different times, or we might be given derivatives of the function at two different times. But when we have the same time, the same input for both the function and its derivative, this is called an initial value problem. And we can think about this from like physics class or Calc 1, where we might know an acceleration. So that's a second derivative. And we're given position and velocity at a particular time and asked to find our function. So you've got some experience with these sorts of problems from previous classes. Okay. And so one of the questions that we'll be looking at is whether this specifies just a single function, if we can have multiple solutions here. Okay. So hopefully that makes it a little bit clearer what an initial value problem is. If we're looking at a third order differential equation, we'll need to know a value of the function at a particular time, the derivative at a particular time, and then the second derivative at the particular time. Okay. All righty, so let's do a quick warm up with this. So all solutions of the differential equation, second derivative of y plus y equals 0. So this is some differential equation where our second derivative is negative the original function. And if you think for a minute about what that might look like, you may have in mind that if we think about our old friends sine and cosine, that the first derivative of sine is cosine, the second derivative of sine is negative sine x. And similarly, cosine satisfies this as well. So if f of x equals cosine x, its derivative is negative sine x, and its second derivative is negative cosine x, which is negative f of x. Just the original function negated. Okay. All right. So it turns out that all solutions of this differential equation have the form a sine x plus b cosine x, where a and b are constants. So every single solution of this differential equation looks like just a sum of sines and cosines. So your job is going to be to solve the following initial value problem. We have this, our differential equation, second derivative of y plus y is 0. And we know that the position at time 0 is given by 3, and the velocity at time 0 is given by 2. So we are able to already because we're given it, we know that all solutions have to look like f of x equals a sine x plus b cosine x. Okay, so take a moment, pause, and think through how we could figure out how to satisfy these two conditions, that the function at 0 is 3 and its derivative at 0 is 2. Okay, so what we're going to do is just evaluate this general format at our initial time, and we're going to see what it boils down to. Okay, so our initial condition is that at 0, this function should be equal to 3. So we plug in 0, and sine of 0, of course, is 0. Cosine of 0 is 1. And so this just gives us b. And if we're going to satisfy the initial value problem, this b better be equal to 3. Okay. So we can say now that f of x must be equal to a sine x plus 3 cosine x. All right, then next up, let's try and satisfy this second condition about the derivative. Okay, so I'm going to take the derivative of this function. Okay, we get a cosine x minus 3 sine x. That's our derivative function. And we're going to evaluate it at 0. Okay, so at 0, we have a cosine of 0 minus 3 sine of 0. And of course, cosine of 0 is 1, sine of 0 is 0. And so this is just a. Okay, so our condition was that the derivative at 0 should be equal to 2. So that means that a must have been 2. And so we've successfully found our solution. F of x must be 2 sine x plus 3 cosine x. Cool. Great.